All right, so 6.1, number 3. Now, this is kind of an interesting one. We're talking about the amount of impulse required to get your body from a standing stop to maximum velocity. How much impulse was required to get you to that speed? Now, some of the sharper ones among you have probably already figured this out. But in case you haven't, and don't feel bad if you haven't. Some people, it's just going to come right to them. If it hasn't, let's just go through it, okay? So, the impulse is equal to the change in momentum. And if you think about it, the change in momentum is equal to your final momentum minus your initial momentum. See? Mass times velocity final minus mass times velocity initial. Notice that mass is, there's no F by the, or an I by the M because your mass isn't changing. You're just going faster. I know, maybe you're thinking the reason I'm running is I want to lose weight, but it's not going to be as quick as that, okay? So your mass is going to stay the same. So let's just plow through this, okay? In my case, my mass is 108.9. My final velocity is 5.6 meters per second. kg. My mass, when I started, was also 108.9, but if I'm starting from a dead stop, what's my initial velocity? Well, it's 0, isn't it? Which means this whole thing is equal to 0. So when I multiply this together, I get my final momentum, which you figured out earlier, came out roughly to 610 kilogram meters per second. Subtracting 0. It's 610 kilogram meters per second. Now, you can express it that way. You may notice that our symbol for impulse is force times the change in time. I could also write it like this, 610 Newton seconds. Newtons times seconds. You could do it that way. That's if you want to think about it as the impulse needed to get you up there. But there it is. Yeah, we're starting from a dead stop. It does make the math easier. The fourth problem, not going to be quite as easy, okay?